Okay, so on Tuesday, we did an example of a boat question, right? And this is another of the boat question types, okay? We did a rowing across question. This is a going across question. All right. First thing I want to tell you is I love what I saw as you guys started this question. And I know a bunch of you are kind of stumped. You're kind of at a point where like, I don't know where to go from here, okay? But what I saw was people trying to visualize the situation, because people wrote it down, they drew some pictures, and then they were like, you could see them, trying to see it in their head, what was going on. And that's exactly what you have to do with a question like this, okay? When we do the math of this question, you're probably gonna go, oh, because it's not a mathematically challenging question, okay? It's the kind of question that that I've been telling you about, that Mr. Dickey and I are working on giving you more of, so that you see them before the diploma exam. It's a contextually difficult question because you have to visualize it. There's a lot of information in there, some of it important, okay? But you have to figure out how it goes together. So the first thing you want to do with a question like this is do what you guys were trying to do, which is visualize it. Okay? If I want to end up going straight across a river, so if I start here and across the river is at the board, and I want to be straight across from where I start, I don't row that way, do I? If I row that way, I'll end up over there, because the current will carry me downstream. I want to get there, which means I've got to aim over there. It's no different than if you're like throwing something on a windy day. You don't throw it directly at the target, because if you do, the wind will blow it away from the target. You have to throw it into the wind a little bit so the wind carries it back. Okay? If you play golf, this is an especially big one. Okay? If you aim at the green on a windy day, you're going to miss it by 20 yards. Okay? Because the wind is just going to carry it to the other side. So you correct for it by aiming into it at an angle, giving it a heading. All right, that's what we mean by heading. I'm going to go this way. I'm not going to go this way. I'm going to aim this way so that I go this way. Okay, that's what this question is about. So when we diagram it, okay, we'll draw our river that we're told is 50 meters across. Okay, so that's north, okay, because it said the current was east. We know the current is 1.8 meters per second to the east. Here's the piece of information that people miss in this picture, and it's helpful. They tell you which way your resultant points. Where do you want to end up in this question? If I start here, where do I want to end up? Straight across. Agreed? Okay. So then they told me, draw your resultant here. I want to go straight across. That's going to be my average velocity. The fastest I could possibly row is 2.5 meters per second. So I've got to point this way in order to end up going this way. For the first time since we started doing vector addition, our resultant's not the hypotenuse of the triangle. That's what's hard about this one the first time you see it. Every other time we've done one of these, the resultant has been the hypotenuse. Not on this one. If I row into the current, I'm going to slow down a little bit because the current works against me. The resultant doesn't always have to be the hypotenuse. It is most of the time. But in this situation, it's not. So this side is your 2.5 meters per second. This is your heading. Okay, do I know two sides of the triangle? then I can find my heading now, can't I? I'm going to let you do the rest of the question now that you see the diagram. Hopefully that diagram kind of makes a bit of sense within the context of that question. And I'll give you a few minutes to finish the rest, and then we'll go over it. So looking at the rest of this question here, right? The heading I can find right now with trigonometry. I know the opposite side, I know the hypotenuse, so I can just do trigonometry and get this angle here, okay? So I'm going to say that the inverse sine of 1.8 over 2.5, okay, will give me my heading. Oh, sorry, I forgot to start my calculator there, guys. So second sine of 1.8 divided by 2.5. Okay, so this person is going to have to row 46 degrees west of north. Okay, because this way was east. The river was flowing east. So this direction here is west of north. 46 degrees. Okay, which, if you think about it, makes sense. If the river is flowing east, I need to point this way so that I get pushed back to straight across. Here's what can help you make the jump from, I can see this on paper and I can kind of figure most things out on paper, to being really stinking good at physics. If you can see it in the real world, if you can take it and make it something you've experienced somehow, it'll make more sense. Because when you go out there, the laws of physics have to be obeyed. They're laws. They just happen. There's nothing you can do to stop them. Okay? On a windy day, if you want to hit a target, you don't aim for the target. You aim against the wind a little bit and the ball comes back to the target. Okay? It's stuff that you've experienced in your life that you do instinctually because it's something that just happens. So if you're ever on a context question, not all contextual questions are equally fair to everyone given their life experience. Okay? But you can usually find something that's at least analogous to it. This was a boat going across a river. But if you play football or baseball, okay, or you've ever played catch with somebody, or you've thrown a snowball on a windy day, that's the same thing. Okay? You can find something in your experience, in your life experience, that's similar to what's being done on the board, and you can go, oh yeah, I would have to do this. That kind of makes sense. That's when you can make the jump to being really good at physics. Okay? It's why I tell people, being good at math doesn't make you good at physics. Okay? I've had some really, really strong math students who struggled mightily with physics because they couldn't do what I just described to you. They're like, just tell me how to do the math. Just tell me what math to do. I know how to do the math. No, you have to see it. You have to see what to do, see how it happens to get to the math. The math of this, that was one thing. Okay? The other part of this is a V equals D over T calculation. The river is 50 meters across. I need to find this because this is the velocity that points across. Once I know that, I just do V equals D over T and I know how long it takes to get across. Once I know how long it takes to get across, I can figure out how far downstream I'll end up. Okay? But that stuff has to all come together from a place of, I gotta see it happening. I've gotta know what it looks like. Okay? So, on that note then, the next step is, I need to know how big is the velocity? How fast am I actually going across the river? I know how fast I'm rowing, 2.5 meters per second, but that's not how fast I'm going because the river's working against me and I'm slowing down a little bit. Okay? If you've ever ridden your bike in the wind, you know how that feels. The wind makes it difficult. You could ride way faster given how hard you're pedaling, but you're not going faster. Okay? So we got V equals, okay, D over T, or sorry, V equals on this one, Pythagorean theorem or trigonometry. I've got the sides. This is the adjacent side. Okay? I would just go just use cos here and go cos of the angle I just calculated, 46 times 2.5, and I'll have that set. Oh, 2.5. Okay, so while I might be rowing at 2.5 meters per second, I'm only going 1.7 meters per second across the river. And now that I know that, and I know how far I have to go, I can figure out how long it takes. 50 meters divided by 1.7 meters per second. Just like, this is now just like the other boat question we did. Oh, sorry. Not 5, 50. Okay, 28.8 seconds to get across. Okay, I mean, that makes sense. It's 50 meters. I'm going less than 2 meters per second. Okay, it's going to take me a while to get across. Okay, so I've got 28.8 seconds. Now here's the last part of it. If I'm going across for 28.8 seconds, am I also going downstream? Oh, sorry, it doesn't ask me that. Why does it? Sorry, I meant to put it on there because how far downstream do I end up? It's a trick.
0.
0. Question told me I'm going straight across. I've done this before as just an experiment. I actually didn't count the question. Okay, but I had a whole question like this, and then I had like a part D. How far downstream do I end up? You wouldn't believe how much math I saw for that question. Even though in the question it specifically stated you're going to end up straight across the river. Okay, people just, whoa, because they didn't picture it. Okay, it wasn't that they weren't smart, they just didn't picture it. Okay, I threw them off with all the other stuff I made them do. That's what they do on the diploma. They make you do a whole bunch of stuff, then they ask you something simple. Okay? And because you're so thrown off by all the work you've done, you insist in your mind that I must do more work like that. Okay? And you don't. If you see it, that question takes you that long. Okay? If you don't, you might do a bunch of math to prove something wrong. Make sense? Weird but true. Okay? It's just those things we got to watch for. So let yourself do what I saw you guys doing at the start. Okay? Let yourself do that. Picture it. Try and see it happening in front of you. Think of something that you've experienced that might be like that and see what happened. Those physical laws will govern the same things we do here. I can't give you a question that doesn't obey the same laws that real life does. Okay? All right. That got very metaphysical there. Okay. Try this one. Planes are boats in the sky. So this is a boat question, but it's about a plane. Okay, so let me ask you this question. Okay, we said there were two kinds of boat questions. Rowing across, where you don't end up straight across the river, and going across, where you don't point yourself straight across the river, but you end up straight across the river. Which kind of question is this, rowing across or going across?
Rowing.
It's a rowing across. This plane is not going to go straight. It's headed straight, but there's a wind. It's not going to go straight. Dave, can I get your help from there? I'm going to just stand up. Okay, I'm going to this out here. All right, so what I'm going to have you do is start here, and I want you to kind of walk towards that board in a straight line, and I'm going to push on your shoulder just a little bit. Okay, so if Dave just take a walk, walk straight. He walks straight. That's the only vector. Okay, you can come back here. Okay, now if this is the same situation as this question, and Dave tries to do the same thing, can't go straight. He wants to. He's walking straight, but he doesn't go straight. Okay, thank you. right? That's the kind of visualization you have to make, okay? I see this plane, it's pointed north, but there's a wind, it's pushing it in the other direction, okay? So what's happening is, you've got the vector of the plane, 225 kilometers per hour, and you have a wind, okay? 112 kilometers an hour, that's a very strong wind. That's like a Chinook. Okay? Even in that other question, did I still draw the vectors tail to head? Okay, like if we go back to that last question and we look at my picture, the red line was the resultant. These were my two vectors. I maybe didn't draw them in that order, but they're drawn tail to head. Okay, and they showed my resultant. And I'm doing the same thing in this boat question. There's the plane's speed or velocity. Here's the wind's velocity. I sure hope they mean to go that way, because that's the way they're going. Okay? If I don't correct for the wind, I'm in real trouble. This is huge if you're sailing. Okay? You've got to rudder the boat. You've got to have the sails pointed so that they're catching the wind, but you don't generally want to go the same way the wind is going. So you've got to rudder the boat, okay, and make it go in another direction while harnessing the thing that's making it go. Okay? So, what's the velocity of the plane referenced to due north? Okay, that angle is of north, it's east of north. Okay? So that'll be the direction that we're going. All we have to do is Pythagorean theorem. That'll get us the 251 kilometers per hour. Okay, and then we do this. That'll be 10 to the minus 1 of 112 over 225. Okay, and that'll get us our 26.5 degrees east of north. Was there very much work in that question? 2 bits of math that you've been doing since the 8th grade. Okay, well, maybe not the trig part, but Pythagorean theorem, I know you've been doing that since the 8th grade. Okay, you've been doing Pythagorean theorem for a long time, and that's all you were required to do there. Okay, so it's the picture, it's the story the question is telling you that can make it difficult. All right, that's the message I want you to take home with you. Okay, is that you can do these. The math is not the hard part. Okay, the hard part is you don't have a lot of life experience yet. Okay, soon you'll get to the point where I'm at, and you'll live in my world, which is not scary. Okay, but it's the world where when I see something happen, I can immediately identify the physics that are going on. It annoys the heck out of my family, especially my wife when I do it. But that's the way I see things, and you'll get to that point too, where you'll be like, oh, well, I can make Newton's second law work for me to get this big heavy thing in the back of my truck without having to be a Hulk, because I'm not. Okay, but I can figure it out. That's the point we want you to get to. All right, on that note, you got the rest of the class to work with your group on the map. Okay, little bonus bit of time there.